Hey everybody, Dr. Asalahi here. So this is going to be a second video on some of the basics of Excel and how to use some of its features. So with that said, I'm going to go ahead and share my screen here. So as you can see, I already have Excel open. I have a blank workbook open for our reference. And so as you already know by this point, Excel is a really powerful computation tool. And so we use it to perform calculations. And we always start a calculation with an equal sign. If you try to do a calculation, let's say 7 plus 4, without an equal sign, it's just going to sit there. It doesn't really know what to do. So anytime you have a calculation, you want to start with an equal sign in front of the string of arguments, and then it will calculate things for you. One of the great things about Excel is that it utilizes what's called automatic cell referencing. And so whenever you are using calculations in Excel, performing calculations in Excel, you can refer to cells with values or other formulas in them. So for example, in cell C3, let's say I just put the single number 9 here. And then let's say in cell C5, I want to perform an operation of square root, and square root is SQRT, open parentheses. And see, it says square root of a number. So I could say square root of 9, close parentheses, and of course we get the number 3. But instead of hardwiring this 9 in here, I can hit square root and click cell C3 here, okay? And so on cell C3, I can perform the square root of cell C3 and get the number 3. Now, if I change that number that's in cell C3, let's say instead of 9, I change it to 16 and I hit enter, my operation in cell C5, my square root operation, will automatically update the calculation because it's not actually taking the square root of the number 9, it's taking the square root of whatever number is in cell C3. So if I put the number 112 in cell C3, it's going to perform the square root operation on that number. So think of it as you're taking the square root of the value in that particular cell. And not just with square roots, mind you, but with any kind of mathematical operation. Okay. So that's just one simple thing, automatic cell referencing. All right. Also, Excel is fantastic for plotting purposes. If you want to plot data or functions, it's great for that. So let's make up an example. I'm going to type here example, and I'm going to say plot, or let's say generate a scatter plot of the data. Okay. Now let's make a table of data. Let's call B6, let's call that X, and let's call C6 Y. So these are just labels. And I'm just making numbers up, 1, 2, 3 for my X values. And let's make Y 4, 5, 6. Okay. And let's go ahead and format this kind of nicely. We can center justify this and, put some borders around it. And let's say we want to generate a scatter plot of this data. So under solution, I'm going to type solution here, and I'm going to go under insert, and over here in the middle panel, we have charts, and we have a few different chart options. Let's use this scatter plot as our chart option. And I'm going to right click, and I'm going to hit select data. I'm going to click add, and then the series name, that's just the name of the chart. So you can give it a name. Let's call it, scatter plot. You can name it whatever you want. And then series X values, you want to highlight the numbers that are the X values. Okay. So I'm going to highlight the numbers 1, 2, 3 here. And then the series Y values, I'm going to highlight the numbers 4, 5, 6. Don't grab the label, just grab the values and hit OK. And we hit OK again. And then I'm going to zoom out a little bit and look at that. We have this nice little scatter plot. Now, this is not formatted very nicely. We can make it look better, okay? In math and engineering, whenever you plot something, you always want to have axis labels. So on this little plus sign here, where it says chart elements, we can click that and we can click axis titles. And we can add some axis titles. Well, this horizontal axis is X, and this Y or vertical axis is Y. And so now we have some labels here, okay? Now, again, some people are very picky about their formatting. Again, notice all of our font is in Calibri 11, so we can click the chart itself and click home, and we can change that to Times New Roman, 12-point font if we want. We can highlight everything. We can do a select all, Control A, or just manually select things and change the font maybe to Times New Roman 11. Okay, so that's how you can create a simple scatter plot. Let's say you want to put a trend line through this data. All right. So if you right click on one of your data points, right click and hit add trend line. All right, you get another window over here in which you can add a trend line. Now the default is linear. So before you just hit OK on things, you need to look at your specific data and figure out, do you have a particular kind of data that warrants a certain type of trend line? For us, this is clearly linear data, so I'm going to keep linear here, but maybe you have data that makes a curve shape. So maybe you want to fit a polynomial of some kind of order through that data. Polynomial order 2 is a quadratic, for example. Polynomial order 3 would be cubic. You have some other options here. You have exponential, logarithmic, power, so on and so forth. So again, when you are plotting data and you want to insert a trend line in Excel, don't just hit OK a bunch of times and go with the defaults. You need to think about specifically what kind of data you have. So again, we're going to stick with linear here. You can display the equation on the chart here. And if you look at this equation, this is giving me the equation of this trend line. All right, so what we have here is we have this equation, y equals x plus 3. This is the linear equation that fits a line, a straight line through these 3 data points, okay? And again, if you follow the same steps, you can do this for data that has a different shape other than linear, okay? So that's a quick tutorial of generating a scatter plot of data. Let's click the plus sign here and add another sheet. And let's do another example, okay? Here, I'm going to type the word example again, and I'm going to say create a plot for the function y equals x, and I'm going to say x squared. Now, remember, right this minute, we're not doing any calculations. This is just, typing a sentence like you would in Word. You want to get into a habit. Don't use that caret symbol, the raised to the power when you're typing a sentence, okay? That doesn't look really nice. So you can highlight this to right click and format cells and click superscript and check that out. Now you've got a nice little y equals x squared label, okay? So it says create a plot for that function. So I'm going to type solution here. Now for this particular example, we don't have any data, okay? We just have this function. So what you can do is create your own table with this function built into it. So how about I say x and y, and I'm going to create or come up with reasonable independent variable values. Okay, so remember, in general, you have an independent variable, which for our purposes is x, and you have a dependent variable for which our purposes is y for this example. So you have to think, if you want to plot a function in Excel, you need to think of what are reasonable independent variable values for that function. Well, y equals x squared is a polynomial. It's a second order polynomial. In mathematics, the domain of a polynomial function, especially of a second order polynomial function, the domain is all real numbers. So you can pick any x values you want for this. Now, if this graph of this is going to be a parabola, of course. So if you want a nice, smooth parabolic curve, you want to pick some negative x values and some positive x values. So I'm just going to pick some reasonable values that are in the domain of this function. How about we do -3, -2, -1, 0, and then a 1, 2, and 3, okay? And now over here on the y column, how do we evaluate x squared? should we say equals x squared? No, that doesn't make any sense. You want these y values to be taking your x values and squaring them. So what you want to do is click the cell. Remember automatic cell referencing, raised to the power of 2. So this is giving us y equals x squared. And then what you can do is you can drag this down and it will automatically calculate x squared using automatic cell referencing that we have here. Now you may be thinking, well, Dr. Asalahi just said don't use the caret top, and he used a superscript here. Yes, I did that for labeling purposes because what I typed here is just a sentence that we're not actually doing any calculations. This is just a problem statement. But for calculation purposes in Excel, if you have a power, you need to use the caret symbol, or what I call the caret symbol, which is on the number 6 on the standard keyboard. So I'm going to go ahead and format this a little nicer. I'm going to, put some borders around it. And then what we can do is we can go insert, and we can click the charts panel, and we have a few options here. Let's do something a little different. Let's connect these with scatter with smooth lines and markers. I'm going to right click and hit select data, go to add, and then this is going to be quadratic. So I'm going to call this quadratic data. And my series X values, I'm going to highlight the values themselves. Series Y values, highlight those values, and hit OK, and OK again. And I have this nice looking parabola. Again, we want to add axis titles. Okay, always label your axes. This is X, and this is Y. Okay. And if you want to add a trend line, you can right click on one of the data points. Right now, these points are not connected by a trend line. It's points connected by smooth curves. Okay, so it's not actually a trend line. If you want to add a mathematical trend line, again, you right click on one of the data points and you hit add trend line. And should we just go with the default linear this time? No way. Okay, this is clearly quadratic data because y equals x squared is a quadratic. So we're going to hit polynomial. Obviously, it's order 2. And then if you display the equation on the chart, what do you get? Well, you have your equation displayed here. Now, you may be looking at this and you may be saying, well, wait a second. This is giving me y equals x squared plus 7e minus 15. What does that mean? Well, in your calculator, and maybe you learned this in a science course or a math course, E is typically the symbol for times 10. So this means 7 times 10 to the raised to the negative 15th power. Okay, that's 0 point and then several zeros and then the number 7. So that's essentially a value of 0. Okay, the reason why Excel does this sometimes is Excel is programmed based on regression analysis when it adds a trend line. And regression analysis often involves an error term or an error function of some sort built into its analyses. And so that's a numerical analysis technique that you may learn in another math course. So basically that's 0. It's adding in an error term in its numerical processing. So whenever you have a number and then capital E and then a big number, especially if it's a big negative number like negative 15, you can just take this term as 0. So essentially what we just have here is y equals x squared, which matches our function that we evaluated with these input x values and got the output y values. So that's going to be the conclusion of this quick video that's just giving us a quick tutorial on plotting in Excel. So thank you for watching.